Welcome to this video from Erudite Training, which is looking at the safety implications of incorrectly specifying AC switches for use in DC systems. As DC systems are being used more extensively in domestic properties, this is a problem that could cause a significant risk to life if the wrong switch or isolator is specified. To visually demonstrate the differences between switching AC and switching DC, and also to see the potential risk, I have used a DC knife switch as shown. The principle is the same as in an enclosed DC switch, but with the advantage of being able to see what is happening inside. The key to the operation of these switches, making them suitable for DC, is the quick action. This type of switch has a set of spring-loaded contacts which suddenly open the circuit when the springs are fully extended. You will see this in action later in this video. In order to show the effect of using an AC switch, for some of the clips I have modified this with the cunning use of a couple of cable ties. These disable the quick break action and basically turn this DC switch into an AC one. Please note I've been working on DC systems for over 35 years and took all required safety precautions, including correct flame retardant PPE, when carrying out these experiments. Please don't try this at home, as they say. For the first video clip, I'm using the switch in AC mode with the cable ties in place. Only a single pole is being switched for this clip as well, and I'm switching a nominal 10 amps at 110 volts AC. If you look very closely, you can see a very small spark at the point that the contacts break. It did not matter how slowly I operated the switch, the spark was only tiny. The reason for this is that on an AC supply, the voltage being switched zeros every hundredth of a second, at which point it also kills the arc between the contacts. This is not the case with a ripple-free DC supply, as we shall see. For the next clip, I used a single pole of the switch in DC mode without the cable ties. For this part I am again switching 10 amps, but now at 110 volts ripple-free DC. Just to explain, if I had just used a rectifier without a smoothing capacitor, then it would have behaved like AC and not shown the effect. Now you can see the quick break action in play. Whilst there is no significant spark on closing the switch, as I open it, you can clearly see a significantly larger spark compared to when I was switching the same AC current and voltage. The speed of the switch opening is out of my control, in that it stays closed until the springs pull the contacts apart. That happens when the switch contacts are far enough apart that any arc is broken, but it is important to understand that that is voltage dependent. The higher the voltage, the larger the gap required. For the next clip, the switch has the cable ties in place again, so pretending to be a single pole AC switch, but I'm still switching 10 amps at 110 volts DC. As you can see, slow breaking of the contacts is now possible, and the resultant arc is quite spectacular, not to mention dangerous. It is possible to hold the contacts apart in such a way that the arc just continues, as would be the case where the contacts are not a sufficient distance apart when fully open. As well as the immediate risk of fire, the switch contacts may well closed or just end up burnt and high resistance. That high resistance may well cause a hot spot and overheat in use, potentially causing a fire. You will see, if you look carefully, that there is still current flowing and voltage on the secondary side, even when the contacts are apart, but the arc is jumping the gap. If this was a circuit breaker, then disconnection may well not be achieved in sufficient time to prevent damage. In the next clip, I demonstrate switching two switches simultaneously. Unfortunately, this didn't work as well as it would in an enclosed switch due to a slight flexing stopping both sets of contacts opening at exactly the same time. The effect can still be seen though. Once again, I am switching 10 amps at 110 volts DC. With two sets of contacts switching, this cuts down the possible arc significantly. It also increases the contact clearance once fully open. It actually doesn't matter from this point of view if you switch positive and negative, or, as in this clip, two switches in one conductor. The effect is the same. This method is often used on contactors where the connections are looped through to series the poles for switching DC. In this clip, I'm still switching 10 amps DC with AC switching and have gone back to a single set of contacts. This time I'm only switching a nominal 25 volts though. You can see that the arc is significantly reduced even though we are switching the same DC current with a single pole AC switch. Had I gone the other way and increased the voltage to say 230 volts, then the arc would most likely have destroyed the switch and put me in danger. It really does make that much difference. This last clip uses the same 10 amps at 25 volts DC but has double contact AC switching with the cable ties in place. You will see that the arc is less again, demonstrating why different configurations of switch contacts and different voltages can change the maximum current rating of a switch, contactor or isolator. You will often find that switches and contactors that are suitable for both AC and DC switching have a lower voltage and or current rating when used to switch DC. It is therefore very important to read the manufacturer's instructions, and you must comply with these. In summary, you should now be able to understand why using the incorrect switch for DC is potentially very dangerous. It really makes a massive difference, and electricians specifying the wrong switches and isolators may be risking the life and or property of their customers. Erudite Training offer a range of electrical courses from beginner to designer. We always teach the subject properly, not just coach for exams. As a technical consultant for City and Guilds, the IET, and sitting on various standard committees, I make sure that we always teach the right content. There are many myths and misconceptions in the electrical industry, and you won't be taught these by us. Please check out our website at www.eruditetraining.net and search for our reviews on Trustpilot. Thank you for listening, and I hope to see you in the future.